Hello everyone, welcome back to our video tutorials. So for today's video, we will solve again a passport problem on the fluid mechanics, specifically on the gravity dams. Okay, so this is the particular problem that I prepared here. So before we start, if hindi ka pa nakapag-subscribe sa channel natin, please consider to subscribe and click the bell icon para ma-notify kayo if ever mag-upload ako ng mga bagong videos. Okay, and also please follow us on our Facebook page to be more updated rin. Okay, so without further ado, let's start to solve this problem. So here we have the situation. The unit weight of the gravity dam shown is 24 kilonewtons per cubic meters. Okay, so we are required to calculate the following problems. So by the way, may binigay na coefficient of static friction that is 0.5. Okay, that is the coefficient between the dam and the ground surface. Okay, so let's start. For number 1, the total force exerted by the water on the dam. So basically, this is just the hydrostatic force, okay, exerted on this portion. So looking this in this view, so this will be our hydrostatic force here. Okay, of course we have derived that formula from our previous video, so diretso na tayo. So by the way, we are to analyze here the 1 meter strip of dam lang. Okay, that is the common analysis dito. Okay, so by this formula, gamma bar H area. Okay, so our bar H here, since the height of the water is 6 meters lang, that should be half of this 6, and our area is this one, this rectangular projection. Okay, so gamma of the water is 9.81, bar H is half of 6, or that is 3, and the area projected is 1 times 6. Okay, so we have 176.58 kilonewtons. Okay, that is for part 1. Sobrang dali lang. Now, how about for part 2? Calculate the overturning moment. Okay, so ano ba yung overturning moment? So, ganito siya i-analyze. Yung overturning moment is yung moment na magkakos ng tipping ng ating dam. Or look at this animation. Ganito yan. And by the way, this distance here should be 1/3 of this height of water. Okay, or actually you can calculate the eccentricity, then i-compute natin to, minus lang, or diretso na tayo dito, 1/3 of this height na lang. Okay, proven na yan, or derived formula na yan. So that is 2 meters, 1/3 of 6. Okay, now yung overturning moment dito is yung magpapatip ng ating dam pag ganito. Look at this. Klaro ba? Balik natin. Because of this force, it will cause rotation about this toe pag ganito. Okay, so exaggeration lang yan. Okay, so it will cause overturning moment dito. Let's call that OM. And that OM is obviously that is just this force times this distance. Okay, for part 2, that is just 176.58 times this distance. Okay, and that is 353.16 kilonewtons meter. Okay, so no need to memorize formulas lang. Just simply basic statics lang. Okay, now for number 3 dito, ang hinahanap is the resisting moment. Ano naman yung resisting moment? From the word resisting, ito yung magpapastable ng ating dam. And it is due to the gravity loads, or from here, that is due to the weight of this dam alone, or weight of the concrete. Okay, let's call that WC. Okay, buong weight ng concrete na yan. Okay, and we are to calculate this distance here. So, yung moment na i-cost nito, that is this weight times this distance, yan yung magpapastable ng ating dam against overturning. And that is what we call the resisting moment. Yan. I-stable na yung dam natin pag ganyan. Klaro ba? Okay, but here, mas mahirap siya kunin yung distance dito. Magva-variance theorem pa tayo. So, ang gagawin natin dito is hahatiin natin yung dam natin into simple polygons lang. Or pag ganito. By the way, ito yung magiging resisting moment or stability moment. And hahatiin natin yung dam pag ganito. So, we have a rectangular polygon and a triangular polygon. So, hahatiin natin yung weight pag ganito. Ayan. Let's call this W1 and let's call this W2. Okay, ano yung purpose natin? Bakit hinati natin? Para malaman natin yung mga distances nila at madali natin kunin yung moments. Okay. Ito yung mga centroids ng polygon ito. So we can calculate this distance here. And that is just, take note, at the rectangular form or polygon, yung centroid is nasa gitna lang. So from distance here up to this point, kung saan magtitip yung dam, is 4.2 minus half ng 0.6. Okay? 4.2 minus half ng 0.6 and that is 3.9 meters. Okay, now ito naman. Distance dito. So ano ito? So take note, this is a triangular polygon. Okay, so recall, the centroid of a triangle is 2/3 from this point. Okay, 2/3. So dito, 1/3 dito. Okay, so take note, we need to calculate this base dito. Or diretso na tayo. Diba ang base na ito is 4.2 minus 0.6. Ayan. So this distance here up to that point will be 2/3 of 4.2 minus 0.6. Ito yung base natin ng triangle dito. So that should be 2.4 meters. Okay, klaro. So i-substitute natin yan. Now the resisting moment here, ito, that is just W1 times 3.9, W2 times 2.4. Okay, that one. So we need to calculate the W1 and the W2, or that is just the weight of the concrete. So from the basic formula, weight is gamma times the volume. So that will be like this. Weight 1 is gamma 24. The volume here is 0.6 times height 7 meters, this one, times the perpendicular distance 1 meter length. Okay, we analyze 1 meter strip. So we have 100.8 kilonewtons. Now the W2 naman, that is just the same, 24 times this volume ito. So again, 1/2 of base. Ang base natin is from here up to that point lang. So 4.2 minus 0.6 times height na 7 times perpendicular length, or yung strip natin 1 meter. And that will be 302.4 kilonewtons. Okay, then substitute dito. Ayun. Okay, so we have the resisting moment is this one, that value. Okay, dali lang. Now for number 4, ano ba yung hinahanap sa number 4? Factor of safety against overturning. Again, the factor of safety against overturning is just the ratio of the resisting moment over the overturning moment. Actually, may video na ako about dams. You can check this on my playlist. Okay, mas maiintindihan nyo yun. Bakit ganito yung formula. Okay, so substitute. So we have this RM over OM and we have 3.17. Okay, so this is very safe, no? Pag nangyaring mas lumiit ito sa 1.0 yung factor of safety, meaning mas malaki yung moment na magpapa-overturn sa dam natin, meaning unstable yung dam. Okay? So, how about for number 5? What is the question? Okay, for number 5, factor of safety against sliding naman. So, from part 4, yung factor of safety against overturning, yung magpapa-overturn. Now, dito against sliding, so we have, by the way, against sliding, ganito yan, para hindi kayo mag-memorize, just analyze dito. Okay, tingnan nyo. Ano yung magpapaslide sa ating dam? Walang ibang force dito is, kundi itong hydrostatic force. Okay, look at the animation, ha? And by the way, ito yung formula. The frictional force or maximum available friction divided by the PSL. I denoted this as P sub SL, meaning yung force na magpapaslide sa ating dam. Okay, Look at the animation. Ganito yan. Pag sobrang laki na yung force na magpapaslide dito, may probability na magsaslide yung dam natin pag ganyan or magtra-translate. Okay? I hope klaro ito. Ibalik natin. Okay, so ano ba yung frictional force dito? Maximum available friction. And take note that we have a normal reaction dito sa ibaba. And let's call that Ry. That is denoted commonly in the books as Ry. Reaction along Y. And the resisting force or resisting friction is always oppose the probable movement ng ating dam. Or magiging ganito yan. Dapat i-kontra niya yung movement. Okay, and let's call that friction. And take note, friction from the basic formula from statics, no? That is mu times the normal reaction on the ground. And that is mu, and the normal reaction here is the Ry. Okay, so here we can substitute this dito. Or we can say that the frictional factor of safety against sliding is mu Ry over the PSL natin dito, yung magpapaslide sa ating dam, is the hydrostatic force na kinimpute natin, which is this one. So, substitute. We have mu here, 0.5. And by the way, yung Ry natin dito, just sum up forces vertical lang. Ry is equals to the vertical or the gravity loads dito, which is 108, ito, plus 302.4. Okay, divided by the hydrostatic force, or mas general yung force na magpapaslide sa ating dam. So we have calculated the factor of safety against sliding, 1.14. So medyo critical na siya, malapit na siyang mag-1. Okay, anyways, safe pa rin naman siya. Okay, so that's it. So if gusto nyo pang mas i-go deeper ito, may previous videos ako sa dam, calculating dam, where we derived formulas there, and also we calculated the pressure at the ground. Okay, so that's it. I hope you like this video and give this a thumbs up. So thank you for watching, and bye bye.